Hello. In this video, we are going to consider a numerical example. In the previous video, we learned three different methods: p-value approach, t-statistic approach, and critical value approach. We are going to apply them to this numerical example, and we will see if they are actually consistent. And the theory was a little bit more complicated, but at the formula itself is quite simple, and you have exercised the same algebra many times, so applying the method is not that difficult. Let's think about this example. I'll consider I-beams. I-beams are these steel beams used for construction. So like it's I-beam because it looks like I. The shape of this end is I. So the I-beams are standardized. Their sizes are standardized. So there are many different sizes, several different sizes. And in this example, let's simply consider the smallest I-beam, which has to be 80 millimeters tall. So this must be 80 millimeters. 80 millimeters. And of course, it's very important to use the correct size I-beams for the safety, right? It's constructed. You are making a building out of this using this, so it is very important to have the correct sized I-beams. You would like to test that. So I am going to use these hypotheses. I believe that my I-beams are correctly sized, 80 millimeters. But the alternative is, if it's not correct, then the mean would be different from 80. So I use x as a random variable for the height of a randomly chosen I-beam, and mu is its mean. Mu is the mean population mean of x. So x is the height of an I-beam. I measure a certain number of I-beams, and say x is random, so maybe manufacturing errors or measurement errors can happen. And suppose that you have a random sample of 400 I-beams, and you obtained from the data a sample mean of 79 millimeters, which is 1 millimeter smaller than the correct size, and standard deviation is 10 millimeters, right? So I'm curious if the 79 millimeters is 1 millimeter smaller than what it has to be. Then how serious is that? Is that significant difference or not? 1 millimeter difference. Do you have to take it seriously, or can we just ignore it as a measurement error? So let's first you find the t-statistic. Oh, there are not many numbers. It's quite easy. Pause the video and find the t-statistic. If you don't remember the formula, go back and find the formula. Use the formula that I presented earlier. Simple. 3, 2, 1. So this is the t-statistic. Difference, x bar minus your belief, standardized by the standard error of the sample mean. Right? So plug in the numbers. Square root of 400, the sample size was 400, which is 20 squared. So square root of 400 equals 20. And as a result, your t-statistic is minus 2. Your t-statistic equals minus 2. And now, and remember, we do not need the significance level to calculate the t-statistic. So I did not specify the significance level yet. Then now fix the significance level at 1%. Excuse me. Then what is the condition to reject the null hypothesis? At 1%, which number do you have to compare the t-statistic with? 3, 2, 1. So the answer can be found easily from an earlier slide. The answer is 2.58. So it is it is rejected if the t-statistic is outside plus minus 2.58. 2.58 was the z-value corresponding to 1%. So so you are going to reject H0 if the standardized difference is greater than 2.58. And we just found t equals to minus 2. Then just make the decision. Do you reject it or not? Everything is given. I gave you everything. 3, 2, 1. Up. The answer is no. You do not reject H0 because this means you can accept up to plus minus 2.58, and your observation is only minus 2, which is within plus minus 2.58. So that's the acceptance region. It's within your acceptable range, so you cannot reject H0. So it's not rejected. Then let me ask you another question. What would happen if the significance level increases to 10%? Recalculate, go through the same steps, find the threshold, and compare that with your t-statistic. The data is the same, t-statistic is the same, and then determine if you reject or not. Three, 2, 1. The threshold is now another typo is 0.05, not 0.005. So anyhow, the threshold should be 1.64. 1.64 is the threshold, and now your t-statistic is outside of the thresholds because it's even smaller than the lower threshold, lower endpoint, minus 1.64. So you have to reject H0 here. And remember, we did not reject H0 at 1%, but we do at 10% because higher alpha implies more rejections. So that happens here. And now, next, find the p-value. P-value can be found 3, 2, 1. So we use t-statistic minus 2. So you just need to do the last step. Last step of p-value is to calculate probability outside of plus minus t-statistic, right? Outside tail probabilities outside of the t-statistic. So we have minus 2. So you have to calculate smaller than minus 2 and greater than plus 2. And then if you use Excel, you will get 4.55%, right? And then, okay, it's fine. Then, given this p-value, the candidates are 1%, 5%, and 10%. Among them, find all significance levels at which H0 is rejected. Three, 2, 1. But you don't need much algebra. So remember, H0 is rejected if p-value is smaller than alpha, right? So if you reject, so like p-value means you observed minus 2, and minus 2 is top 4.5%, right? Let's say it's simply top 4.4% suspicious, unlikely. Its unlikeliness is within top 4%. But when you choose 1% significance level, that means you are going to reject only 1%. So you reject only 1%, then 4% outcome is not rejected. So, which means the null hypothesis is rejected if p-value is smaller than the significance level. So if significance level is 10%, you are going to reject top 10%, but your observation is top 4%. So it should be rejected. That means, given the p-value, any significance level greater than 4.55 will reject the null hypothesis. So the answer is D. And without reading this p-value, C, for example, C is wrong. A and C is wrong, automatically wrong, because if you reject at 1%, it should 10% should reject it too. So as the higher the significance level is, the more rejection happens. So it cannot be. It should be whenever 1% is included, all the higher significance level should be included. So if you understand the logic, the relationship, you can easily cross out two options and improve the chance of choosing a correct answer when you randomize it. Okay, so this was the idea. Okay, this was the p-value approach and t-statistic approach. They are similar, and as you can see from this, p-value approach is particularly useful when you change the significance level. So when you have the p-value, you can see when it will be rejected, at which significance levels it's going to be rejected. It's automatic. And t-statistic was also useful, and because it tells you the direction and how much the difference is, how large is the difference. So t-statistic is -2. So the sample mean is 2 standard deviations below the belief, and it's on the negative side, smaller side. So this is how we use the p-value and the t-statistic in our example. And next, changing our gears, fix the significance level at 1% and find the corresponding critical values. Also, critical values, remember the formula is quite similar to confidence intervals, and if you don't remember, go back to the slide and do the math. It may take a little more time, so pause the video here and do the math. 3, 2, 1, this. Once you get the formula, it's easy. It's a simple plug-in, like the confidence intervals. mu0 is your belief, which is 80 millimeters. Z alpha over 2 is 2.58 because alpha was 1%. So this number is also automatically given. And standard deviation 10, sample size 400. So it's simple algebra. Use calculator. Then, by the way, as you see, in this computation, we do not need X bar. X bar was 79, but we did not use this number at all. But we used alpha here. Alpha should be given. Then comparing these critical values and your observed sample mean, can you reject the null hypothesis? Make the decision. 3, 2, 1. The answer is no. Remember, the critical values are given, and between the critical values is the acceptance region, and outside is the rejection region. In this case, the lower critical value is 78 something, but your observation is 79. So, given this absolute critical values, your observation is here, inside, right? Even though it's negative side, it's inside the critical values, so you do not reject H0. So you don't reject H0. It will be so don't reject H0. The decision is simple. And now suppose that you change alpha to 10%. What are the critical values? I'm going to stop the video here and continue in the next video. Thank you for watching, and see you in the next video.